Cool. Okay. So if you haven't had much time to do much, I'm assuming we're just going to continue on with the normal stuff.
Yeah.
Sweet. Okay. Okay, we're doing the multis. I believe we ended up question 4. Yeah, because that
Oh,
was
we
the
did that one. That
0.38
was the one
one.
that you did for me.
Say again?
That was the one I think that you did for me because I
Oh,
couldn't
yeah, yeah.
understand.
Okay. That was with the 0.38% thing,
Yeah.
percentage of games, get the standard deviation. Yeah, okay, that was the Z stuff. Do you want to repeat that or continue on with the
Yeah.
next one?
Yes, please.
Yeah, certainly. Go for it.
3.
That's correct. Yeah. Nice. Nice and fast too. Um, cool. Okay, that's that one. This is the transformation side of things. We can do it just in case it'll show up on a SAC, but worth pointing out, this sort of thing has never really been on an exam before. You got mean of 6, standard deviation of 3, and we're trying to map that to the standard normal. So going from these parameters to the parameters of the standard normal. We've got to figure out which of these transformations describes that.
I mean, I guess I gotta whip out the equation for the distribution.
Yeah, the equation of it would be nice to know, or at the very least, where the standard deviation and mean terms fit into it. You can
Yeah.
kind of already guess what they're going to be.
Yeah, kind of. Standard deviation is like it's like on the denominator of the coefficient
Yep.
on E, and then also on the denominator on the for the power of E,
Yeah, correct. It's in that X spot ish. Mm-hmm.
and then mean is on the numerator for the power
Mm-hmm.
of E, X minus mean.
Yeah, correct.
Sorry about that.
All good.
Okay. I honestly kind of want to eliminate most of those options. I think it's A.
Eliminate most of the options and go for A. Okay. Um, what were you seeing to eliminate?
Because you know how the mean is, oh never mind, the mean is 6. Never mind. Sorry about that. I thought the mean was 3.
Ah,
Um
okay, you got these back the other way. Yeah, okay.
yeah. Okay. Would I be right in saying that it's between B and C?
It's between B and C. Yep,
Yeah,
yep.
okay. Um, I'm gonna say C because that looks like it'll cancel out the transformations.
Yeah, yeah, it's perfect. Yeah, when you multiply the y by 3, because because it was as a denominator of 3, when you put it on the top, obviously those are going to cancel down. Yeah,
Yeah.
chill. Nice and easy. Question 6, let's see, there's any different. Mean 100, standard deviation 14. 20% of occasions takes more than k liters. We've done something like this before. Maybe we'll do one just for today, at least.
Okay, cool. Is it D?
Is it D? D is correct. Yeah. Very good. Just an inverse normal type approach there. You would have, I'm assuming, flipped that to the 80%.
Yeah.
This sort of question you've done before, where you've got the table, the mean and standard deviation of those things, and you're trying to figure out who was best and worst at the things. If you want, you can do that. Otherwise, move on to 8.
You're talking about question 7?
Yeah, 7, you
Oh,
did that pretty quickly last time.
that was fine.
Yeah.
No problem.
Question 8 should also be kind of similar. I'm not seeing anything that's too different anymore. I guess, yeah, just as many of these as you want, and we want to extend responses.
Cool. I guess we'll do 2 more of those ones, and then
Sure.
we'll go in the other way around.
So 10 then 9, or?
No, I'm looking at question 8.
Oh, yeah.
Okay. No worries. A.
Yep. A is going to be correct for that one. Very good.
Honestly, for this one, you don't even need to solve both of the like intervals for
Yeah.
question 8, because all of the numbers on each side are different.
Yeah.
Apart from the first for A and D, the left side. Actually no, they're also different.
Yeah, a little bit.
They're all different, so then you can just do one side and you figure out straight away.
Yeah, exactly. A nice little tactic to minimize the amount of effort you have to put in. Absolutely.
Question. Okay. D.
D is good. Yeah. And that was relatively fast as well. Nice. So you're starting to get those more complicated, solving the mean or standard deviation questions. That's good. Did you want to knock out 10 or move on to extended?
We'll move on to extended. I think this is going to be tough.
Yeah, it's looking a bit weird now.
Is it usually tech active or no?
Yeah, definitely tech active for
Okay.
external response. Okay, so I mean, it's a bigger question, but only because it's telling you to do a lot of things. Yeah. For the recording, this is basically just a bunch of inverse normals right here.
Sorry about that.
No worries.
Okay. Um, Technically speaking, couldn't this sort of be like, because we're trying to cover 100% of all the schools, right?
Yeah.
Is there a possibility this could just go to infinity or no?
It's a good point. So the scores that are involved, yeah, for the upper bound, you would just say from some value to and above. It's maybe a
Yeah.
bit more ambiguous on it, because an infinite score would obviously be quite strange, but technically, yeah.
Yeah, so I'm literally gonna say 0 to infinity.
Because that also gets a bit weird when you start considering like negative scores,
Yeah.
because the normal distribution should also be valid for negatives as well. Um, so yeah, if you just say like for the upper bound it's like and above, and for the lower bound it's and below, you'd probably get away with that.
Okay. But so is that what the book says, or the book's like,
Yeah, yeah, I'm looking at the book when I'm saying that.
so they also like say 0 to infinity?
No, no, they say so. Well, they've given all the answers for each of the boundaries, and for the upper boundary thing for the top 10%, they've said the x value and above. And for the lower boundary, they said scores less than whatever the number is. That's the wording they've used.
Let me see. Okay, it's gonna be like something like 117 for the top for the upper bound.
117, that's going to be a bit high.
First, I was gonna say like near 80 because 80 would be 99.7% confidence interval.
Oh, okay, you're thinking about those.
But no, what I did was I did inverse normal
Yeah.
at like 0.99999, like a lot of 0.999s, and then
Inverse normal with what parameters?
50, 10,
Yeah.
and then I put the area as like like 0 point and then like a lot of nines.
Oh, why?
Actually, not sure.
Yeah, that's the weird bit there. Oh, hang on. Are you looking at this as if like, okay, you've got all these categories. What's absolute lower to absolute upper?
Yeah.
Yeah, no, that's not what they're. Okay, I see why you've interpreted it that
Oh,
way.
cool. Yeah. No.
They've said what are each of these boundaries cutoff points going to be?
Okay. Yeah.
Yeah,
Okay.
okay, that makes more
Look at
sense
that
why you
now.
did that.
Bottom 10% um will be cut off at around 37.
Yep.
Then the next is 20%. Okay. Obviously, we'll start at 37 and
Hmm.
we'll cut off at 45,
Sure. Yep.
44, 45, and then the middle will start there and then end at 55.
Yep.
And then the second highest people will end around 63.
Yep.
And then the last, I mean,
Hmm.
I don't know, like,
Yeah. That just wherever that goes above.
yeah,
Yeah. Yeah. Those are good. Maybe the only thing I would touch on would be making sure there's no doubling up on the boundaries. So, like, you wouldn't have, for instance, like the 62 exist in both the upper bound and the moderate and the high. You want to do
yeah.
62 then 63, but that's whatever. Yeah, that was just a sequence of inverse normals. So not necessarily tough, but just a bunch of the same stuff you're already used to doing. I wonder if that's going to be the theme for most of these. Although I am noticing a continuous thing here, which, sure. But I guess I'll get there when I get there.
The amount of anesthetic required to cause surgical anesthesia in patients is normally distributed. Okay. Mean of 50, standard deviation of 10. The lethal dose? What? Like, how would they? Okay, it's kind of cool they have data on how
Yeah,
the distribution of like lethal anesthesia is.
yeah, I was thinking exactly that when I read it. I'm like, huh, I wonder where they got that data from. It's a bit concerning. Although it's good that the means of both are significantly separated from each other.
Okay,
Although the standard deviation's a bit, yeah.
okay, hold up. What? Is it gonna be 0.9%?
0.9, yeah, 0.9 is a percent. Yeah, not as in like 90%, but 0.9. Yeah,
Yeah,
about that.
0.9%.
Yeah, that's good. I can imagine a few ways you might have done that. They've got a Z transform version in here, but I don't think you need that.
No, I didn't bother with that. I did
Yeah.
in normal, and then I just stuck it in a normal CDF.
Yeah, that's what I was thinking of doing. Yeah, very good. Cool. See what question three's got for us. This one looks like it's just a bunch of. No, no, they are different a little bit.
Um, about 16%.
Yeah, yeah, about that. If you're seeing these as fairly easy, you can let me know to skip them if you want. Because one of the things about like the probability chapter is the difference between extended response and anything else is like not really that different, considering pretty much all the probability has a scenario attached to it.
Okay.
So if they are
Yeah,
getting a
but
bit samey,
let's go through maybe one of the easy ones. C1 with like the functions that looks a little bit fun.
yeah, like it might be chucking in some continuous there.
Um, well, II is going to be about 97%.
Yep, about that. That's good.
Okay. The year 12 are getting the results in about 2 days. Should
Oh
be
yeah, I've got it in my calendar, and
exciting.
yeah, it'll be curious to see. Because I wonder, because I'll get their results, but I don't think the report that gets published comes out the same day. I don't,
Oh,
I
okay.
don't think it's the same day. I'd have to have a look. It'd be interesting to see not only the grade distribution, but also like the number of people doing methods. Because I think over the
Yeah.
last 2 years it has been declining, which I found really strange considering that the way we're going is more technologically advanced, not less. So you'd think there'd be an uptick in people trying to go for those types of jobs where you are involved in those sorts of things. I'll be curious to see if anything is changing this year, if the trend will continue.
Is it about 3%?
3% seems about double what you're looking for. Oh, what's
Oh,
in the book anyway.
maybe if we'd control enter twice.
Might have done.
Oh yeah, yeah,
You did? Yeah, okay.
yeah,
Fair enough. So yeah, about 1.6-ish%. Is that what you had the first time?
yeah.
Yeah, cool. Easy enough.
All right, yeah, that makes sense. Yeah, I
Cool.
see. Me, the company's advertising manager, wishes to climb to 90% of our titles. Okay. Bold business claim.
hmm A statistically backed, accurate.
Um, 53,593 kilometers.
Yep, that'll do.
Because I got 592.24 at the end, but
592.24. Yeah.
because you probably wouldn't say that it like lasts like this
Yeah,
many kilometers in like 242 meters
yeah,
as it round up to the next number.
yeah. I get you. You wouldn't.
You
Well,
would round
let's
down
see.
because then that's just inaccurate.
Well, I would say like conservatively speaking, in the real world, you probably would round it down just so you can be even more. So it's like 90% and above. Versus if you round it up, then you're technically not hitting 90%. You're hitting 89 point whatever.
Yeah.
Um, Maybe that's why in the book they had it rounded down.
Oh, okay. My bad then.
I don't know. There's no
I think it would be helpful if they could, yeah, say
yeah.
round to the nearest whole number or something like that.
Yeah, we see issues like that in the textbooks where they just don't really bother with the rounding to nearest or 90% and above. That would be another way to imply the way the rounding should go.
Anyways,
Yeah.
what is the probability that a customer buys 5 tires same time and finds that they all lost? Oh, okay. So that's basically going to be like the probability of a tire lasting more than 72,000 kilometers to the power of 5.
Yeah, because it's all of them lasting more than that. Yeah, that'll be it.
I'll get that for you
Yeah,
then.
do
Anyways.
that first, and then I'll ask a follow-up question on that.
Okay.
It'll be a very
Um,
small number.
yeah. I mean, I've got that E thing, which it was like times 10 to the power, like whatever the
Yeah,
number is, right?
it's at roughly 3.7 e negative 11.
Yeah, that thing. Yeah.
Yeah, okay, cool, that'll do it. Follow up on that. If I had said instead of all of them lasting more than that, I had said four of them lasting more than that.
Then we have to do a Bernoulli sequence, right?
Yeah, Bernoulli sequence. That's it. Cool.
I think it's actually kind of useful. I wish I knew that before I did probability this year.
Mm. Yeah, okay.
I don't know how I forgot because I never really like went how they when we got those questions without Bernoulli sequence, how we used to solve them. Some like crazy like long.
Yeah, it was basically tree diagram stuff, effectively. Because you'd be like,
No, but
okay,
like
I could
there was
have,
no like there was no order. It could be like any of them.
yeah.
Like say like with 5 tires.
Hmm.
Actually,
Because well, when I say tree diagram, I mean like ABC, and then from there you've got BC or whatever, and then you just look at all the combinations that had a total of four out of the five or whatever it would be. You can do a tree diagram. You can do it by just like you can do it kind of like you do this in programming with by binary where you have like your ones and zeros, and if you want to count all of the numbers in binary, you toggle the first digit, and you toggle the second digit, and you toggle the back there, and I mean I'm pretty proficient with binary that I can sort of toggle through all those different combinations of like on off.
yeah,
Um, and those can effectively be like your A, B, C. Is it like on off? And you can see all the different combinations. So you can see for any given A, B, C, whether it was included or not. You can see how many ways.
yeah.
But yeah, that was C. Question 4. It'll get to this one. So let's see how we go.
0.1056.
Yep, that's good. Nice and easy. I don't know why they feel so compelled to use the Z stuff in the answers.
Yeah.
It's really not necessary.
Okay. So for some reason,
Hmm.
my number is more than one.
More than one. Okay.
Yeah. But just for a shot in the dark, is it 37.3792?
Yeah. So I'm assuming you did the fraction two different ways. Because the only way you
Uh,
would get a number greater than one would be if you had a denominator on the numerator instead.
Honestly, all I do is I do normal CDF 605 to infinity,
Yep.
right? And then do that's like the denominator of my fraction.
Yeah, should be.
And then I do normal CDF 607 to infinity, and that's
Hmm.
a new, and I get my answer.
I mean, yeah, that's what it should have been. And that gave you the 0.37-ish?
Yeah.
Yeah, okay. So the thing greater than one, maybe you had it reversed?
No, because I divided it by point 0.1 again, because of like, I thought that was like, I thought 0.37 was my intersection.
Oh, sure. Okay. Yeah, gotcha. Well, fair enough. Hmm. Yeah, okay.
Okay, innocent tubes from company B are distributed shops in box of 10. Okay. .07, 0.08.
Yeah, that's on the way to the answer.
Now that's the okay. So that's the probability of one of them lasting more than 605, right?
Hmm. Yep.
So then just want to run that to the power of 3.
Almost.
Oh, never mind. Bernoulli equals time.
Yeah, there you go.
Actually, no. You don't need to do Bernoulli sequence. I can. There's that thing on the CAS.
Well, yeah, okay. I thought you like yes, it is the Bernoulli sequence, but done by the CAS rather than by the hand.
Yeah,
Yeah.
I actually don't know why I keep on resorting to do it by hand.
Yeah, well, good luck doing this one by hand.
Yeah. Just to confirm, it's binomial CDF for Bernoulli sequence.
Yeah, yeah, CDF. CDF for a range of possibilities, PDF for a single possibility.
Okay. Lower bound, upper bound. At least 3. Okay. 3, 10. About 3.7%.
Yeah, about 3.7% is correct. That's good.
Oh, the full question.
Yeah, that was a double whammy there. They're like, hey, here's continuous, but also binomial. And all of that in the normal distribution chapter review. Which I guess it's cool that they do chuck in the other stuff as as it appears in the textbook.
More
But
like, I guess that's more exam
yeah,
style.
it's getting a lot closer to exams, which is good because it's like you would do discrete and get discrete stuff. You would do binomial and then get binomial and discrete stuff,
Mhm.
and so on and so
What's the
forth.
probability, I guess?
Because you do need to build that the skill of being able to flip between different probability types. This is almost even actually harder than what you would see in a exam. Usually, when they introduce
Really?
a new type of topic, they'll do just that one. So, like this question should have been, at least as far as the exams are concerned, would be just continuous, and then the next one after might be binomial within that. Usually, they'll when they introduce a new type, they'll stick with just that type for at least one of the questions before moving on.
D
Yeah.
is 3 decimal places. Okay. 0.078.
For D, that's a little bit off, at least by the answer I'm seeing here.
Lasts longer than 605 hours. Okay.
Oh, okay. Did you read this bit here?
These local lighting store stocks, for instance, fluorescent globes from both company A and company B in equal quantities. The customer comes into the store and randomly selects a single fluorescent globe. Okay. Alright. Yeah, let me do that. Is it 0.092? 0.092?
That's better. Yeah, 0.092. So yeah, the background information there was basically to say, hey, 50-50 split on which one you get, and then that's basically the weighting of whether you're using the normal or the regular CDF. Cool. Make sure I'll kick this up here just in case you need that. Part E.
Is it a 3 decimal places? Okay. 0.847.
847 is suspiciously looks kind of like doubled from what it should have been. If you halve that, what do you get?
It's just a coincidence. That means there's no way I.
Say again, sorry.
That's just a coincidence. I probably
Okay.
don't know what I'm doing.
Yeah, sure. How'd you get there then?
Um, I just thought of the probability of company uh wait, hold on, can I just try something before
Yeah, yeah.
yeah, never mind. I just plugged the some of the numbers that we got from before, like
Mm.
one being the probability of it just lasting more than 605 hours overall. Uh,
Well, that would have been the denominator, the probably lasting over 605,
yeah.
and the
And
numerator.
the numerator, I think I put as 0.07. Yeah, I put as 0.07,
Yeah, see,
which
that's what I
is
thought you might have done.
right.
Um, what, ignoring the actual numbers, thinking about the conditional probability formula, what actually goes in the numerator?
The intersection between the two
Yeah,
events.
intersection between the two. So these kinds of scenarios where you've got choose A or B and then go from there, that's
Ooh,
best visualized with a tree diagram sort of thing.
so I think what I was meant to do is the probability of company B having a good globe, the one that lasts over 605, was I meant to multiply that by 1/2 before putting it in the
Correct.
fraction?
Yeah, because you
Yeah,
got
okay.
the way the intersections work on a tree diagram is it's the product along the path. That's the
Yes.
intersection.
Yep.
So I thought it was a bit suspicious that you're a half off, basically. Um, so it sounded like you plugged in more or less the right numbers, but yeah, just missing that one part to it.
I'm so close to being a good question.
Yeah, I'll pretty much always do these sorts of things with tree diagrams. Like as soon as this sort of thing comes up here, it's like, okay, cool. We got box A, box B, or whatever it is. Even if it is just a 50-50 at the start, like, yes, you can visualize that, but it's always good to just have it in front of you. Cool. Okay. Question 5 looks relatively short. Find mean and standard deviation. So even without listening to any of this, you can probably already know roughly what you should be doing.
Um, I thought of Z equations,
That's good. Okay.
and I think I tried to be a little too smart and then use a simultaneous.
No, simultaneous is what you should do here.
Really?
Yeah,
Okay.
I don't see an easy way to get one before getting the other.
So this is what I'd put into the thing, okay? So assume X is mean
Yeah,
and assume Y is standard deviation.
sure.
60.4 minus X
Hmm.
over Y
Yeah.
is equal to 0.97.
Okay, 0.97
Actually,
is
you know what?
the...
I've already found my mistake.
Yeah.
The second equation, I equated it to 0.95, but I'm gonna do 0.05.
Well, your fix is also a bit off there.
Huh.
0.97, 0.95, what are those numbers?
They're like the X value.
Are they?
Not the X value, like the area.
Yeah, area. So what should go on the other side of that equal sign if you think about the actual equation you're using in terms of pure letters?
Uh, Inequalities, like
I think so. You've used 60.4 minus mean over standard deviation equals something. Where
yeah,
did that equation come from? What is that equation in terms of just letters?
X minus mean
Yeah,
all over standard deviation is equal to Z.
Z. Okay. You've put an area in the Z spot. You need the Z value that corresponds to that area.
Right. Uh, could you give me some help in this question? I'm not really.
Yep. So the only things you were missing from those equations was the z's there. Those 0.97 and 0.95, those came from the flips of these. Um, the way that worked was, in fact, I can probably get up the previous time we did this. Oh, look at that, it's actually literally right there. Kind of. Scroll back a little bit. This is roughly what the working out's going to look like for these sorts of things. You have your two z equations, and the way you end up getting those z's is via the inverse normal with the probability equations. So I've got these probability statements here that equal some probability. That's going to be where you're putting your 0.95 and your 0.97 in those spots. So you've got to create whatever these equivalent equations are going to be for that and do your inverse normal off of that.
Right.
Do you want to go through that, or are you happy enough to try that yourself now?
I think I can do that.
Okay.
Okay, so the mean is 60. Wait, let me just check how many decimal places it asks for.
Mhm.
Um, one decimal place. Okay, 60.0, and
60.0. Yep.
standard deviation is going to be 0.2.
0.2 is also good. Nice. Yeah, those are a two-parter. Pretty much anytime you've got to do both mean and standard deviation, very likely these inverse normal type stuff is going to come into play. In fact, even if it's just one of them, you should probably also need the inverse normal to get a Z. I think that's how that always has worked. Unless there's some where you get the Z off rip, but those are on the rarest side, I'd say. So yeah, that's that one. And then using the result, I mean, this is sort of whatever at this point, but might as well knock it out now that you got it.
Percent of region is going to be 9%.
9%. Okay. Um, it didn't say what to use for rounding, so fair enough. They did have 10% there. I'm wondering if that's just because of the way you've rounded it differently, or if you've used the rounded versions of the mean and standard deviation, and maybe that's why. I guess I'll ask again, like, did you plug in the full version of the mean standard deviation when doing that, or?
Sorry about that. Um,
Did you cut out
we
again?
did normal CDF, right? I did normal CDF with lower bound 59.6,
Yeah.
60.3,
Uh-huh.
and then mean 60.
Okay, so that's why. It might
It's
have been the case that the rounding of 60 instead of 60.02, whatever the hell it was, that might have caused you to round it to 9 instead of 10.
okay. I mean, it says user result of A, so I was like,
Yes, that's it's cheeky there. Using the result of A, technically speaking, yeah, the result of A would have been the what you actually write in the answer spot. But I guess having done it a couple of times, what they mean by this is to use the actual calculation version. That's what they mean
oh
by
yeah,
that.
I see what you mean. I put 60.02 now, and yeah.
Yeah, does that actually round up to 10%, or is that just
Yes, yeah, it will.
it does? Yeah, okay.
The normal CDF is like about 0.9, and then
Hmm.
yeah, it's actually a decent difference.
Oh, yeah, interesting. Okay, probably from the yeah. What would it be? Maybe the standard deviation is
Because
the
I guess
thing.
the standard deviation is really small
Yeah,
compared to the mean.
yeah, really small. Yeah, that's fair. Really small tweaks on the standard
That's actually,
deviation.
yeah, that's like 1/10 of the standard deviation,
Hmm.
the difference.
Yeah, interesting. By the way, the book did this in like the worst way possible, where it did
That's,
it did two separate CDFs on the outsides and then added those together versus just doing one
Mhm.
minus the insides.
Yeah, I just did one minus the inside. Okay.
Yeah, I don't know what the whoever wrote the answers to these was on something different.
Yeah, I guess he was feeling very mathematically sound.
Just like, hey, here's the hardest way of doing this possible. Enjoy. Um, yeah,
I guess I'll do those in my time if I get the opportunity to.
yeah. I was debating whether to maybe make a start on it with the like, because I started a bit late. We could do another.
Oh no, that's okay. That was a misunderstanding. It's
Oh,
alright.
yeah, okay, sure. I mean, it would be kind of tough to do like a part of this and then come back afterwards. So I guess it makes
Yeah.
sense to naturally close it off here. Yeah, cool. All right. If you do get
Yeah.
time, then those.
I'll be more clear about like
Yeah,
my
no, you're
in the
fine.
future. Sorry about
Fine. It's all good. I stick around here anyway, just in case anything needs to happen. So, no big deal. Anyway, take care.
Thank you.